All right, so I'm hopeful that this is recording. Um, yeah, I guess I'm going to test it. Watch it not work. I'm going to go ahead and delete that. I believe it's still going. So I'm gonna quickly run through this. Hopefully it's only going to take just 10, maybe 15 minutes. But we left off today. Um, We were talking about primary and secondary pollutants and their causes, but I also wanted to touch base on photochemical smog and acid rain. So these two are tied together. Again, modern smog consists of a combination of sunlight, water, and volatile organic compounds. So you bring all those together, and smog essentially is what's created. And there's a process by which it's created. Nitrogen dioxide splits to form nitrous oxide. The free oxygen combines with others to form ozone or more NOx, and then some of the oxygen then gives way to more nitrogen dioxide. And then the VOCs take up more of the nitrogen oxides, stopping them from forming bonds with ozone. So all of that together is really what modern smog is, and it can be incredibly devastating. You guys can see the smog heavy day as compared to the smog-less day in that background photo there. Temperature plays a role in this, especially with smog. There's what's called thermal inversion, which is when a warm layer of air at mid-altitude covers a layer of cold, dense air below it. Um, the warm layer of air trapped between the two layers is known as that inversion layer. So again, if you look at this one image to the right-hand side, it shows the warmer air resting on top of the cooler, denser, and thus lower air. The problem with this is when you have smog that's being released from the ground level, that smog gets trapped in that lower air and it's not able to dissipate. So you get more of those pollutants concentrating in that one air mass, and keeping it towards the surface where humans happen to be, where humans are breathing. Acid rain can be the result of this as well when you get nitric or sulfuric acid that's created in the atmosphere as a secondary pollutant. Remember that secondary pollutants are formed in the atmosphere as opposed to emitted from a primary source point. So make sure that you guys get that down. These can be devastating. Of course, they can wreak havoc on forested areas as well as limestones. That acid does usually travel down to the lowest spots where it gets accumulated. So the question really, I think that we have to ask ourselves at the end of all this is what do we do to control this pollution? The best way to stop pollution is to not generate it. Stopping the point of pollution is the main goal. That can be achieved through ultra low sulfur fuels, as we talked about. Better air to fuel mixtures. So if a car is running too lean, you can change that air mixture ratio. Lowering the temperature of reactions to produce fewer NOx. So if you have a car that runs cooler, it produces fewer pollutants. Using things like catalytic converters, which luckily is now mandated by law. Having fuel injection systems instead of carburetors. These are all things that just helps with that. Having those scrubbers that they used on those flare towers at the refinery is another good example. Putting restrictions in place through legislation is probably the one that has the most long-reaching effect. That's the one that probably is the most utilized of all of these. Um, Ozone. Let's talk a little bit about ozone. We only got three more slides. We talked about ozone earlier in the year, so this is more of a review. So I'm going to run through it quickly. Again, I'm trying to keep this at this point. I'd like to keep it again under 10 minutes. Hopefully more like 7 or 8. But ozone is in the troposphere, if you recall. It is a damaging pollutant. It has a very high thermal index, meaning that it holds on to heat really well. And because of that, it's a major source of greenhouse warming, I should say. It is a major greenhouse gas. However, with all of its downsides, it's also incredibly helpful for us because within the stratosphere, um, and again, notice that I said that it's found in the troposphere. It's found in the troposphere at the point of pollution. But within the stratosphere, it's actually beneficial. So in one place it's a pollutant that causes more harm than good. In the other place it causes a lot of good. So the stratosphere is where we want it. It says in the stratosphere, it acts, I should say acts, sorry about that mistake. It acts as a protective shield against harmful radiation, which it absolutely does. It protects us from UV radiation from the sun, as we talked about earlier today, which is far worse for you because of its carcinogenic effects than a lot of the things, the particulate and greenhouse warming effect that it has. So how is it created? Well, and again, I think we talked about this briefly, but just to run down through it quickly. Solar radiation strikes an oxygen molecule is considered a diatomic molecule because it has two oxygens combined. That oxygen splits. Those free O2s encounter other diatomic oxygen. You can see it. We're on the second layer here. I'm going to use my mouse to kind of show you that. So you have other diatomic oxygens that will come into contact with it. Those will forge together to form O3. But in the process, because this is cyclical, it'll start back at the beginning, where light will strike this. And as it strikes it, the energy from it gets absorbed, and then it goes back to oxygen and O2, and then it jumps back up to the previous one. So it constantly goes through this cycle of O2 plus oxygen to form ozone, and then ozone breaking apart back into O and O2. But every time it breaks apart because of UV, it grabs the energy of that UV radiation, and it keeps it from the surface of the Earth. Ozone depletion was a really big thing, especially with when we had a lot more use of chlorofluorocarbons, or CFLs. However, that has been luckily banned through legislation, and because of that, the hole in the ozone layer that used to be a really big deal when I was a kid is being mended, and I think it's in fact very small at this point now. Refrigerants are the main cause of that, and we have changed our refrigerant from the standard Freon to newer materials multiple times since then. And every time we change to a new material, usually the emissions prospect of that material goes down and it gets better. So, last slide, it's all about indoor air pollution. And again, this one's close to my heart simply because of my daughter. By the way, if I'm going too fast with any of this, please stop it. Make sure that you guys get it down. Again, this is for your benefit. This is to hopefully help you with that APES test. So I wanted to make sure that this was at least available to you, even if you didn't necessarily watch it. Hopefully you do. Hopefully you take that APES test seriously. So because the house is a closed system, air pollutants can easily become concentrated within it, but they can also be mitigated, and that's the good part. Carbon monoxide is a very dangerous air pollutant because in the right concentrations it can actually cause death from asphyxiation. Asbestos is also a big one. We didn't get to talk about asbestos very much, but it's a fibrous material that used to be literally in everything from insulation and paint to all sorts of materials. And the problem is that when they're sealed, those fibers are sealed, they work really well, but when they get frayed, they break off and they go into the air, and then they get lodged in your lungs, and they cause a lot of issues with breathing and cancer. Radon is a radioactive gas that can also cause cancer, and it's found through the degradation of rocks underneath your house. So your basement can have radon in it. VOCs are volatile organic compounds, like we talked about, include things like paints and glues. Anything that have that strong chemical smell, those are volatile compounds that you are smelling. And those cause breathing problems and eye irritants. Formaldehyde, for example, there was a big recall on laminate flooring that lumber liquidators had years ago now because their wood had formaldehyde in it, and it was causing eye irritation and asthma flare-ups and breathing problems. So they had to get recalled. Guys, this is the last slide for this particular little section. Make sure that you read over this chapter. Again, I think it's chapter 15. Tomorrow we'll do chapter 16. But yeah, I'll see you guys then. Thanks for watching.